A transaction indexer transforms raw blockchain data into query-friendly structured formats. Let's discover TX Indexer, the official minimal implementation for Tendermint 2 blockchains. Basically, a blockchain indexer gets the latest minted block from the blockchain and index it into a query-friendly format. It is necessary to reduce the cost of heavy computation. You can then transform this data into a more structured one to use in your decentralized application. Let's imagine a use case of a decentralized blog. A user posts a social content and the blockchain emits a new block with the post. The indexer will index the transaction and its metadata, and it will update my database that can be then used in my applications. It brings efficiency and on-demand blocks data. TX Indexer lets you get from Tendermint chain a GraphQL API and a JSON RPC API for your different use cases, all stored into its database. You can make, for example, real-time dashboard, explorer of your application, complex transaction queries, and since many existing tools are based on JSON RPC, you can plug any Gno data into existing Web3 tool. It is very performant using concurrent processing. A typical use case would be a visualizator of your own token. By using the GraphQL API, you can subscribe to the transaction of the token, which is a WebSocket basically of our created token transaction, so foo20. We'll pass out the useful metrics, so it will build a variable linked to the transaction, can be amount transfer, block 8, the gas used, and push all these metrics into our database. We can use a visualizator like Grafana to display this data into real-time charts. Another use case would be to implement a more advanced indexer using the TX Indexer. By cloning it, you just have to do make build and it is now accessible in the build directories. Let's start our indexer on the test6 network. It will retrieve latest transaction on the network. By going on the listen address of the indexer, we can access the GraphQL playground. And we already have some query ready to be executed. This one retrieves all the packages that import the Gno Land sys validators package, and we have some data that can be processed in a Web2 applications. By knowing GraphQL language, we can create our new transaction. Documentation is available directly on the playground. It lets you retrieve all the schema types as the coins, the block, the ID, message call, or whatsoever. Let's start our indexer in local by doing gno dev dot in the good directories. And by starting the indexer by removing the remote parts, we have access to all the transactions of our local environment. I deployed the foo20 package. We can, by taking the address of my key, setting on Gno Web, and taking, let's say, for example, the faucet command, execute it, and once executed, see it directly on the indexer. By executing this query I just wrote, getting all the latest successful transactions, I can see my latest transaction hash with the gas fee amounts. I can add many other fields available in transactions in the documentation, since transaction is returning transactions. And we can get, for example, the content row, which is just there. So let's write our own query to get all the transactions of our own contract. So foo20, we just deployed. We type query with the name of our package, so get foo20. And by going in the documentation by clicking on this button, we can go on query. And in our case, we'll use get transaction, which take a where filter and order transaction order. So get transaction, where the message is as the value of message call of the functions, so equal to transfer. Package path to the name of the module. And once we set the filter, we set in the body of get transactions the result we want to get. So let's get the hash of the functions. When we execute it, we have no transaction, which is normal since we have no transfer at the time of our token. By setting an address that's not mine and an amount, let's say 10, we can execute the transactions, set the good number of gas, and it's executed. And by going back on GraphQL, our hash is available. A transaction object can return many different objects, and we can as well get the transaction message, which contains the value of the transactions, which in our case is a message call, containing all of this information as the color, sending, package path, and so on. The syntax uses these three little dots to access all the parameters of the message call. It's called an inline fragment. And in that case, we decide to get the color and the arguments. So the color, the arguments, and the amount of token we decided to move. To do a proper balance now of our token, we need to retrieve all the transfer and calculate from zero the amount of a certain user. It is also possible to subscribe to be always on time with the WebSocket by using the subscription keyword. In that case, we replace query by subscriptions, and we want to get the blocks with no filters. And here is our data on live. From this subscription, we can easily connect it to our applications. If you have more questions, I recommend you to check the documentations, which give some example for GraphQL, for example, or the endpoint for RPC with JSON RPC. All the sources are in the description. Thank you for watching and see you next time.